Alright, so this is fiber optics and where to find them. So my name is Felix.
I'm Nicholas Cushion.
I'm Griffin Whiteside.
Alright, so fiber optics, what even is it? There will be an image. But fiber optics is essentially a technology that doesn't use copper wire to transmit information over long distances. And instead, what it does is it actually uses light in order to do that. So you see this jumbled mess of normal wire? That's not what fiber optics are. So click it again. Yeah. So this is not, yeah. So this is a big difference to what we historically had, right? Okay.
The advantage of fiber optics is that they use light instead of voltage, which means you can transmit data faster, which makes them perfect for high bandwidth applications, such as large data transfer between companies.
In data centers as well.
Yeah. So fiber optics work by using total internal reflection, which can hold this.
Oh yeah. So we're gonna do a little bit of a demonstration here on what he's talking about.
Angle it over there so we don't hit anyone in the face.
Yeah. All right. So the idea is that if you hit a laser inside of a medium, there is an angle where the laser will bounce on. See it? Yeah. So don't point it like over there. Yeah. So you see how the laser is bouncing off of the medium right here? It's not fully reflective because this isn't specialized. This is just a demonstration. And the idea is that inside of a fiber optic cable, inside of a glass cable, it's the same principle. Right. So essentially the laser light's going to bounce around in there thousands of times until it reaches its destination. Yeah, and using this, we can transmit tons of data really fast. Yeah.
Yes.
And essentially, it just bounces along
So
here
here
for a while. Hold that end.
Alright, so this is a fiber optic cable. This is another demonstration that we have here. So, hopefully when he shines the laser through there, it should show up over there. Look at that.
The angle at which the light will bounce instead of going through is called the critical angle. And if you hit it just right, there will be no light escaping, which is what these fiber optic cables use to transmit data over really long distances without losing any signal strength.
So you may be wondering, how does light actually transmit information? Because after all, light is a wave. So it's like if you were to turn this laser on and off multiple times, it's the equivalent of having ones and zeros. And if you turn that laser on and off multiple times and do ones and zeros together, you could string together messages in binary, which you could translate into real-world text. So this allows us to transmit data super quickly over long distances in binary. And this is actually how the internet works. So it's very interesting. There's thousands of miles of these cables that go throughout the ocean. However, there are some limits. So the bandwidth is limited by how fast you can flash the laser, because like theoretically, like if I had this handheld laser, I can only flash this. I can only flash this so fast. After a limit, I can't flash it any faster, and it's the same limit. I need to turn this up. It's the same limit with fiber optics. You can only flash it so fast. So actually, one of the professors here has been working on a new type of laser beam, which switches between wavelengths, and that allows for more data to be transferred And the lasers also have colors which allow for more data transfer too, because you have RGB, which incorporates numbers and allows for even more binary text to be transferred.
Yeah, so essentially we are overcoming the limits that have been imposed onto us by early early fiber optic technology. All right, so here are some other applications of fiber optics. So one of them is astronomy, where, as you saw earlier in Mike's presentation, we have these telescopes that actually use fiber optic cables to go ahead and receive information in the form of light from distant stars, distant galaxies, and we actually use that to go ahead and further our study of astronomy and outer space. And another application of fiber optics is quantum computing. So like I said, data needs to be transferred extremely fast, and you also need, along with that data transfer, and you also need there's also a certain application that you can use fiber optics for in quantum computing. So I'm going to go ahead and explain that now. So quantum key distribution actually allows you to send messages even faster than light in theory. And so the way that researchers have been thinking of doing that is actually getting the individual photons, so the actual particles of light that are in light, and entangling them. So quantum entanglement is a quantum property, like a part of quantum mechanics. And essentially, when two quantum particles are entangled, changing like one state, like observing the state of one can change the state of the other, and that happens over long distances, which means that technically, using quantum computing and fiber optic cables, where you would have to send these particles to different places, you could actually transmit information faster than light. So, and honestly, anything related to the transfer of information, fiber optics revolutionizes in this way because it allows you to transfer information at the speed of light. So like he said, data centers, you can use this for business applications, really anything that involves the transfer of information. All right, thank you for listening to our presentation.